Hello. In this video, we're going to talk about the net engagement score. Now, the net engagement score is a measure that you will see all over your survey results. And the net engagement score is really just a way to take the responses to a particular question or the responses to an entire survey and distill it down to a single number. And with that, you're able to compare one question to another, one survey to another, one school to another, and really use that number across different reports. And I wanted to use this video to kind of explain how the net engagement score is calculated, why we chose that particular metric to compare survey results. So if you'll bear with me for a minute, we're going to go to a made-up scenario that has nothing to do with any of your surveys, but this is just a made-up survey that asks respondents how long of a lunch break do they take. And you can see that I've got categories here of 5, 10, 15, 20, 25, and 30 minutes. And you can see what the responses were to that survey and kind of a visual representation down there. And we're going to ask a few questions about these categories right here. And the first question we're going to ask is it ordinal? And ordinal categories are ones that you could put in a logical order. And in this particular instance, 10 minutes is more than 5 minutes, 15 minutes is more than 10 minutes, 20 minutes is more, etc., etc. And so these categories here are ordinal because they can go in a logical order from least number of minutes to greater number of minutes. To kind of give you an example of categories that wouldn't be ordinal, if you did a survey and asked students what their favorite class was, you'd get responses in categories like English, math, science, PE, that kind of thing. And those don't have a logical order. So that would be an example of a survey that is not ordinal. But this one is, since we can put these in a logical order. The next question we're going to ask about our categories is, are they numeric? And the big test there is these look numeric, 5 minutes, 10 minutes, 15 minutes. But the big test is going to be if you took two 10-minute lunch breaks and put them side by side, that equals a 20-minute lunch break. That's logical. You can do that. You can add those two numbers together and get something that makes sense. And so it passes the test. We're going to say, yes, it's ordinal. It also passes the test that it is numeric. Since you can do math on these numbers, these 5, 10, 15, 20, up to 30, and have that make sense. And the final question is it continuous? And continuous data, continuous categories would be answering the question, the difference between 5 minutes and 10 minutes is 5 minutes. The difference between 15 minutes and 20 minutes is 5 minutes. The difference between 25 minutes and 30 minutes is 5 minutes. And so the categories are equally spaced, and you can mathematically prove that they are equally spaced. And so the answer is yes, it is continuous. So when you have categories that are ordinal, numeric, and continuous, you can do math on those. You can do very convenient things with those numbers. For example, you can get a numeric average of this data. And if you take 5 minutes times 1 plus 10 minutes times 3 down to 30 minutes times 10, divide that by the total number of respondents, you can say mathematically and logically that the average lunch break for this sample is 21.8 minutes. And so that's what ordinal, numeric, and continuous data looks like. I'm going to switch over here to a kind of a made-up survey of Likert data, which is in this strongly disagree, disagree, neither agree nor disagree, agree and strongly agree. And we're going to ask some of those same questions. Is it ordinal? Does it make sense to be in this order? Is disagree higher on a scale than strongly disagree? And the answer is yes. Agree is higher than neither agree nor disagree. Strongly agree is higher than agree. So these can go in a logical order that makes sense. So I'm going to say yes, this is ordinal data. Is it numeric? And that's the question we have right here. And it certainly looks numeric because you have the numbers 1, 2, 3, 4, and 5. But just like that other question, we're going to ask can you do math on this? And I'm going to say that if you had one strongly disagree and you put that next to two disagrees, can you add those together and say that that equals a strongly agree, or I'm sorry, an agree? And the answer is no. I mean, that doesn't even make sense. That question of if you add two disagrees together, does that equal an agree? Not really. If you add a disagree and a neither agree nor disagree together, does that equal a strongly agree? Not really. That doesn't even make sense to do that. And so I'm going to say that this is not numeric data. And then finally, is it continuous? Is the distance between a strongly disagree and a disagree the same as the distance between a disagree and a neither agree nor disagree? And again, when you start asking questions like that, it almost doesn't even make sense. And so I'm going to say that no, this is not continuous data. So even though this looks like numeric and continuous data, 1, 2, 3, 4, 5, it really isn't when you start looking at what these categories actually mean. And because of that, we can't just average all of these numbers together. We can't say 1 times 1 respondent, 2 times 3 respondents, down to 5 times 10 respondents, and put those all together and average them together. That doesn't make mathematical sense. And so we're challenged now with how do you take Likert data and distill it down into a single number. And that's where the net engagement score kind of comes in. And I'm going to go to another spreadsheet right here, which is showing, again, real data that is coming out of the Milligan School database. If you look at every survey we've ever done as of right now, and look at what all of the answers to those questions are, this is what you get. So there were 2,386 people said strongly disagree across all of the surveys, the teacher surveys, the student surveys, the superintendent evaluations, all of that. There were 2,386 strongly disagrees. There were 7,353 neither agree nor disagree down there. And what you can see is that the most common answer is this 4, is agree. And if you were to stack all of these answers on top of each other and take the one in the middle, it would be 4. And so what we can kind of conclude from that is that 4 is the normal answer. And I'm trying to be careful. I don't want to say the average answer, because again, we can't do math on these numbers, these 1, 2s, 3s, and 4s, and say that 4 is the average, but we can say that it is the middle. And so we can kind of conclude that 4 is that middle answer, which means when you look at the people who answered 5, they are more engaged than normal. So they have kind of a net positive engagement. On the flip side of that, you can look at the people who answered 1 and 2 and say that those are the people who have kind of a net negative engagement on whatever particular question you're looking at. And so that's what we use as a base to calculate that net engagement score. If we go back here to our imaginary question here, what we can do is calculate a net engagement score. So I'm going to move that down there. The way the net engagement score is calculated is to take the number of people who answered 5 strongly agree, which in this case is 10, subtract from that the number of people who answered 1 or 2, which in this case is 4, so 10 minus 4 is 6, divide that by the total number of respondents, and we get a net engagement score of 0.2. And that is the number that we use to distill a single question or a single group of responses down into a single number. And that's really, really handy for other reports that we have. Now, when you calculate it this way, you'll end up with a number somewhere between -1 and +1, with most of them falling somewhere in between there. So for example, if every respondent answered 5 on a survey, the net engagement would be 1, since it would be the number of 5s divided by, subtract from the number of 1s and 2s, divided by the total responses, so that would end up being 1, since all of the responses would be 5. The flip side of that, if you had a survey where everybody answered 1 or 2, that net engagement score of that question would be -1 by that same math. But again, most of them fall somewhere in between there. So we now have a way to calculate a single number that summarizes a question down into that single number. And so when we go back to the reports, what we see is this net engagement score, which is calculated for all of the individual questions. Something to point out, and I think this is important, is that anytime you take answers to a survey and summarize them down into a single number, you're going to lose some information in that. So for example, this question here ends up with 6 people answered 5, subtract from that the number of 1s and 2s, which is 0, divide that by 12. So the net engagement score for this particular question is 0.5. The net engagement score of this question is also 0.5, 7 5s minus 1 or 2, divided by 12, ends up being the same result. But you can see that obviously these are very different results. So anytime you distill answers down into a single number, you lose some of that nuance. So it's important to look not just at the net engagement score, but also look at what the responses actually look like. But what you're able to do with this net engagement score is then compare 2 questions together and say mathematically that according to this net engagement score, the responses to this question are generally higher than the responses to this question, which are so you're able to do that, and you do that across a bunch of different reports. So this is a report that shows your net engagement score, where it compares to all of the other surveys that were conducted at the same time. And so for this particular question here, let's go right here, has a net engagement score of 0.846. And when you look at all 14 teacher surveys that were done at this time, 0.846 was the highest net engagement score. And you're able to see your rank. Down here, you can go here and see that, for example, this question here had a net engagement score of 0.538, and so that was 5th out of 14, which means there were 9 surveys that were lower than this score. There were 4 surveys that were higher than this score, and you can see that you can compare answers across multiple surveys. This is a report that also uses that net engagement score to say that if you looked at every single survey, that the net engagement score of every survey, all schools that took it, was negative 0.014, whereas this particular school had a net engagement score on this question of 0.385, and so you're able to compare to the survey average net engagement score. And so that is really just kind of a breakdown of why we chose that particular metric, why you can't just average all of those 1s, 2s, 3s, and 4s together, and what we do with the net engagement score across several of these reports. So if you have any questions about the net engagement score or any questions about Milligan School Data in general, please feel free to reach out to me directly at milliganschooldata@gmail.com. Thank you very much.